schedule here. This project, while officially listed on here, right? Myself, Dwayne Fox, Dave Kazak are the official authors on this project. Everybody knows, or at least all the sturgeon world knows, that this really is a decades old idea. I say decade in the title, but it may be 20 years old. When transmitters started going out in sturgeon and other fishes, right? People started talking about where are these fish going to go and how do we collaborate on those projects going forward. And really these discussions came out of the depths of, I call it meeting socials and associated bar rooms. So I have some pictures of the socials up here in the different meetings, and this is just really a handful of the opportunities where researchers got together to talk science and to really nerd out about fish and what's going on in their arrays and between arrays and across arrays. So these conversations date way back and include really a lot of researchers from the very beginning. So if you don't know much about Atlantic sturgeon is on the, it's on the moniker for MATOS, right? It's one of the founding species for these networks and the ACT network and MATOS. But they've been under a coastwide moratorium since 1998 due to low population status, and they were listed under the Endangered Species Act as 5 distinct population segments in 2012, with from Cape Cod South being listed as endangered and from Cape Cod North essentially being listed as threatened due to a whole host of issues I really won't get into today. But generally, they make really large scale coastal migrations north in the spring and south in the fall. And these migrations can be quite extensive. We've had fish from Delaware go up to the Gulf of St. Lawrence. And we know that fish from the Long Island Sound have gone out down to Cape Canaveral. And these migrations are typically inshore, so that causes them to interact with a lot of anthropogenic activities. And you see this, one of the original coastwide papers, if you will, looking at some tagged with satellite tags, sturgeon from the Hudson River, shows that they see kind of these hot spots off the coast and this inshore migration patterns. So we wanted to add on that, and when we started putting out tags off the coast of Delaware, we wanted to know where are they going and when are they going there. So like everybody on the call here, we started with telemetry, putting tags in these fish, putting out receiver networks, receiver arrays, and see where they're going. So originally, what we saw off the coast was that there are some high use areas off the coast of Delaware, but looking into this going forward with the listing of the distinct population segments, we want to see, are those fish behaving differently based on where they respond and where they actually were, the DPS they came from or were at least assigned to. And what we found, looking at timing of arrival by date on the x-axis here, temperature on the y, we see that we do see a significant difference in the arrival of these fish by DPS, but really only between those New York bitefish and those Chesapeake fish. And these data, this slide is really old. If you went to my presentation in Seattle in 2012, I presented this exact slide. It has not been updated since, as I've been working on other things. But we have a little bit of data. We are seeing these migrations that are differentiated by DPS. We again looked at that for the departure, right? And we're not seeing a difference in departure by DPS. So even though they're arriving at the same time off the coast of Delaware, they're not really leaving they're arriving at different times. They're all kind of leaving at the same time. And these data are just from these red dot receivers right here off the coast of Delaware, where we found that it's a pretty important area for Atlantic sturgeon. So what did we find out, right? Obviously, sturgeon get their move on. Tagged off the coast of Delaware from 2009 to 2012, you see the map on the right. We have fish from Cape Canaveral all the way up to the Gulf of St. Lawrence, and just about everywhere in between where there were receivers deployed. There are some gaps that may be because there were lack of arrays or the data hasn't been updated. It's been since updated if there were arrays out. But again, this is an old slide from 2012, almost a decade old now. But this is kind of the founding ideas of the project, right? And these data were originally shared through that ACT network that Kim was talking about earlier with the Dropbox document. I don't even know if we were using Dropbox back then. It may have just been an email going around back and forth. But what we saw was off the coast of Delaware, all these DPSs were represented, and they're going covering most of the range of the species when they leave Delaware. So it's really interesting and really got our minds going, and was really at the heart of my discussions at these meetings. Probably people may have got annoyed at me for talking about how far our sturgeon are going and how many researchers are seeing them up and down the coast over the years. But we were really excited here in Delaware to see our fish go so far. So bringing that to our current project that we recently got funded on, we wanted to determine what these coast-wide scale migration movements by DPS or river of origin, right? A little bit finer distinction, looking at the rivers, not just as general DPSs. And at the same time, we want to confirm the genetic assignment. So as we were tagging the fish, we were taking fin clips, not only us, but most researchers were taking fin clips. Those were genotypes to make those DPS assignments. So when we're tracking these fish going back to their spawning rivers and spawning locations, can we confirm those genetic assignments that were done maybe in coastal waters using this acoustic telemetry and where these fish are going? And our goal really is to provide science-based support to connect these rivers to the observed migratory patterns on the coastal shelf. So are different spawning populations behaving differently on the coast? Are they arriving at different places at different times? Maybe utilizing different habitats, and with the idea to minimize the impact of permitted activities on these different DPSs and rivers. And doing so with some examples would be adjusting the timeline for wind power construction, activities or sand mining, things like that, changing when fisheries happen or how they happen. And also with that, can we identify additional aggregation sites or potential hotspots that are not currently being monitored, right? So given all this insight and watching these fish move up and down the coast, there may be areas that aren't currently monitored, but maybe should be monitored for Atlantic sturgeon movements and habitat utilization. Like we've noticed that off the coast of Delaware. We have a pretty tight, pretty fine scale array in Delaware, but there is maybe a 5 kilometer square area that hasn't been monitored historically, that all of the fish were going to in the summertime. And it was just happened to be a really logistically difficult area to put receivers out. So we avoided it thinking everything else was covering it, but that's really not the case. So we knew that sturgeon were disappearing within our array. And that may be something similar may be happening with that on the coast, right? Where they're not even, the scale of the arrays maybe losing some of the critical areas for sturgeon as they move up and down the coast. So hopefully we can tease that out as well. So to accomplish our goals, we're gonna synthesize the historic telemetry observations from our fish and our receivers, but also from other researchers we're collaborating with and other receiver arrays up and down the coast. And then we'll use those to generate these migration-specific estimates for each DPS or each river. And we're not going to do that on a fine scale, not on an estuary scale, but on a regional scale, more using the estuaries themselves or the rivers themselves as nodes. The within estuary movements, that's really the original questions that most of these receiver arrays were designed to answer. And those researchers still want to answer those questions themselves. So if there's in-river movements, in estuary movements, those researchers that put those data out are most likely gonna look at those themselves, and we're not gonna touch on that and not step on their toes. So as we get partners, we want to give back. So in return for the collaborators will receive genetic assignments of any fish that have not been genotyped. There's a mix of funding and availability of when each fish was tagged, whether it was assigned a DPS or river of origin, and we want to fill in all those gaps. And I think there may be up to 1,000 that need to be still assigned based on discussions with the geneticists who's doing that. And we're also working on, and we being Dave Kazak, looking at a potential sex-based assignment using the tissue sample that's already been submitted to the genetic repository. So there's been some breakthroughs in sequencing of those tissue samples to identify whether the fish is male or female, even from a very young age. And preliminary data has shown this has been really promising for Atlantic sturgeon. So we hope to be able to scale that, confirm that, and then we will give that sex assignment to all of the researchers that are collaborating on this project going forward. So that's a really nice incentive to work with us and share data and share your findings with us. But also, we're going to compile all these data, and this is kind of what MATOS was set up to do. But as Kim said, some of these data go back to 2002, before anybody was keeping a major database. So data is in various formats, whether it's a PDF file or an Excel file or a Word document. But we hope to dig into those, compile all of the detections from each collaborator's transmitters, and then give those data back to them in a usable format from all of the the receiver arrays and receivers that we're given permission to use, so that we have everybody has a nice data set of their own transmitters. And then if they want to combine their data set with other data sets to make a larger project going forward, they can just have that discussion with other authors and other researchers going forward. All of our collaborators, we're going to offer authorship and allow them to have input into the products as we move forward and at every step of the process. So we're not leaving anybody behind or keeping anybody in the dark. So to do this, originally there was going to be a sturgeon meeting in March of 2020. That meeting was canceled for obvious reasons. And in that meeting, we were going to hash out a bunch of data sharing agreements and talk to the community in person up front about what we were doing. When COVID hit, everybody had to regroup. We didn't want to have a 30 people Zoom call with everybody talking. So we thought maybe we could start with a smaller group of people. So the three of us added 5 more researchers up and down the coast, representing different agencies and groups, but serving kind of as an umbrella of we know what's going on in our region. We kind of lead the people that are tagging here, and we can give you some input and some ideas of what may be in their minds. So with that group, we developed a data sharing agreement. We sent out to, we had each of the participants send out to their specific region and reach out to those potential collaborators. And we're in the process of compiling a list of existing transmitters available for use. And with that, we'll complete any of the incomplete genotypes. And then from there, we'll go and mine the array databases for compiled transmitters and then begin to analyze the data. So for that data compilation, that big pulling together, we're going to use some of that traditional ACT approach, right? Using that Dropbox and using the Excel sheet to match data, but also hopefully move into this MATOS model and use a network approach where we can mine the MATOS database and don't have to go researcher by researcher. And with that, if any of the researchers that we're working with want to upload their data, we can help them upload their historic data to MATOS to help going forward. And of course, we're going to do this with permission from all the researchers and all the tag owners as we go in every phase, with any researcher being able to pull out their data out at any time if they so choose. So we're going to request some standard tag data. I see them over time, so I'm going to skip through this a little bit. Right now, we're in the beginning phases of that. We have about 1,500 transmitters that we have metadata for. Hopefully around another 1,000 more to come as we continue to get data in from up and down the coast. Really, we're going to start compiling data over the summer and into 2022, with analysis really beginning in earnest January 2023, once we get everything done and everything caught up to date. So I'll skip through this and just thank everybody. I would put a list of researchers that are helping out with this, but it's really premature. I don't want to leave anybody off, so I'm just going to leave the list to everybody's imaginations. But I thank everybody, not just that's been a project or been a part of this project and will be, but for everybody that's sharing data up and down the coast. If you want to reach out to me, my email's here for discussion. We'll discuss data sharing, collaboration, or if there's any questions about this project or sturgeon in general. shoot me an email, or you can put it in the chat, and we'll go from there. So thank you, everybody.
Great, thanks, Matt. And if you have questions for Matt, and Kim put the email in the chat as well. If you have questions for Matt, drop those in the chat. But we'll move straight into our next talk, which is going to be by Chelsea Black about another data synthesis project called BioTrack.
Okay, can you guys see my screen, my PowerPoint?
Yes.
Okay,
yeah,
great.
Looks good.
Okay, so hi, my name is Chelsea. So I'm a PhD student at the University of Miami Shark Research. So I'm going to talk to you guys about a new project called BioTrack. So while this is using satellite telemetry to identify biodiversity hotspots, I know you guys are mostly doing acoustic work, but I hope that some of you also do satellite telemetry. And then also this project in the future, after it kind of gets going, we do want to expand to include acoustic data. So that's something to keep in mind for the future. So right now, the main project leaders, Dr. Neil Hammerschlag, who is my advisor here at the University of Miami. And then we're working closely with the Marine Biodiversity Observation Network. So if you guys haven't heard of that before, that's a growing global initiative that's composed of regional networks of scientists, resource managers, and users working to integrate data from existing long-term programs. And we really just want to improve our understanding of changes and connections between marine biodiversity and ecosystem functions. And then we're also partnering with the Animal Telemetry Network. So you guys heard this morning from Bill Woodward. So we're really using those two programs to kind of build this project that is BioTrack. So the overall objectives of BioTrack, identify and predict location and timing of biodiversity hotspots of marine megafauna. So we're going to be looking at migratory pathways, see where these species are overlapping and identify those hotspots. And then at those hotspots, we want to understand what environmental conditions are occurring there. So are they going to these areas because of the environmental conditions? When over time, historically, these conditions change, do these hotspots move with them? So we also want to look at where these hotspots are occurring with management areas. So are there gaps where species aren't being protected? Could we focus resources on larger areas, kind of cast a wider net on protecting multiple species rather than looking at singular species? And then we also want to monitor and model if and how these hotspots are going to change over time in response to environmental conditions. So with global change, we want to see if we can predict where these hotspots are going to move in the future. So we're really looking at historical data, and then this is going to be a long-term monitoring project. So it's going to be going on for years, and it's exciting because we're really just getting data in and seeing kind of like what people have to contribute. So far we have 26 different species within the BioTrack project. So we're looking at seabirds, marine mammals, sea turtles, sharks, and bony fish. So we're really looking at migratory species that are going to answer a lot of questions and cover a lot of space. So what are the end products of BioTrack? So BioTrack is going to produce multi-author scientific papers, but then we also want to create data summary visualizations and infographics that we can use to educate the general public, other researchers can use, but also really to inform management bodies to aid in assessments of marine sanctuary boundaries, protection. So we're working closely with stakeholders to kind of figure out, okay, what are the key questions that need to be answered? So that's something that we are just starting and seeing where we need to be focusing our efforts. And we really just want to create large collaborations across researchers and research groups. So it's really interesting bringing together people who haven't worked together before and looking at this big picture of data. So right now, our study area is the Gulf of Mexico, the Caribbean, and the Western North Atlantic. But in the future, like I said, we're also going to be expanding to acoustic work, but we're also going to try to expand and be more global. But we've got to start somewhere, and we can only manage so much data to begin with. So we're still looking for collaborators. Right now, we have about 19 different projects that have joined. So it's over 600 tagged individuals. So if you or anyone you know is working with satellite telemetry in the Gulf of Mexico, the Caribbean, or the Western North Atlantic, my email is here. I can put it in the chat. We also have a website that includes a lot of FAQs about the project and where it's going, and we provide updates. And then you can also learn about the Marine Biodiversity Observation Network there, because we actually have, through MBON, a lot of different projects. So I'm really just a part of the South Florida chapter, and then within the South Florida chapter is BioTrack. So yeah, you can feel free to send me an email. I can answer questions in the chat. Like I said, for now, we're just working with satellite telemetry, but we want to expand in the future to acoustic work. So hopefully in the future, a lot of the data that you guys are currently working with and partnering with ATN, that would be included in BioTrack efforts. So yeah, that's kind of all I have for you. And email me with any questions or if you want to join our project.
Great, thanks, Chelsea. We have a little bit of time here. Does anyone have questions they might want to ask of any of the speakers we've had so far today, you know, Chelsea or Matt or any of the introductory speakers? If you do, you can raise your hand and Kim or I can call on you. And if you can raise your hand in the reaction by clicking on reactions, and then there's a raise hand function in there.
It looks like Kimberly has a question.
Hi, can you hear me?
Yes.
Hi, this is Kimberly Murray. I'm at the Northeast Fisheries Science Center, and I had a question about how, I think you alluded, this is for you, Kim. You talked a little bit in your presentation about integrating the database with OTN. And I was just wondering if you could describe how that works. I have a project in OTN. I don't think I have it in ATN, and I'm wondering how they crosswalk together.
Yeah, so if you're already reporting receivers or tag detections to OTN, every kind of quarterly, our ACT network database, ACT MATOS, gets connected to OTN's database. So regardless of who you report to, your tags or receiver detections will be shared amongst everybody.
Okay.
That helps.
Okay, thank you.
Yeah, and I don't know, I see John Pye's on here and there's some other folks. If John, do you want to talk a little bit more about the technical side of that?
I don't think we can hear you, John.
Right, hardware mute, very, very useful stuff when you have kids running around. So that is the way it goes. That's exactly right. So the independent ACT MATOS database can pull OTN's database and match its detections to tags that we're holding, or match its tags to detections that we have among our partners. So if you're reporting to us, you're reporting to Kim. If you're reporting to Joy Young down in Florida, if you're reporting to Alex Hearn in Ecuador, or to the FERG folks down in OTN Brazil, every database will cross-reference your tags and your detections across all these other nodes and produce a report for you if you're a receiver holder of which researchers you've crossed paths with, or all your detections if you're a tag holder. And the way that we've arranged it is that your tag agreement, the agreement you make to the place you submit your tags, is respected by all the nodes that are cross-compatible, so that we're all bound by your network's tag sharing policy.
Great, thank you.
Yeah, thanks, John. We might have time for one more question. Does anyone else have a question they want to ask? Well, I don't see any other hands raised here, so I think I will introduce our next speakers, who are Courtney McSween and Aaron, is it Legg? I don't know how to, I'll let you pronounce your last name, but presenting some updates on acoustic telemetry technology and innovations from Innovacy. And I see you have your virtual booth set up there, so it's giving us all the conference feel, even though we're sitting at home. So take it away.
Thank you. All right, yeah, so thanks for having us, everybody. So my name is Courtney McSween, and this is Aaron Legg. So we're happy to be here and to talk about ACT and Innovacy and acoustic telemetry and how that plays in. So basically, you may have known us as VEMCO, but now Innovacy. And so basically in our fish tracking business side of things, we offer a broad array of integrated solutions that can be tailored to pretty much any aquatic environment. So the more broad scale fish tracking that you're familiar with in the ocean, as well as fish passage, narrow rivers, lakes with our high residency equipment. And then we also offer consulting services. Many of you have probably taken advantage of the BPS side of things, but we do also offer solutions where we can actually, take a study from start to finish for you. So we've got to run through some of our latest stuff that we're pretty excited about and want to share. So first up being predation tags. One of those age-old questions is, are you still tracking what you think you're tracking? And so we've developed a predation tag available across all 3 of our frequency lines, and they allow you to investigate your predator-prey behavior, understand impacts of invasive predators on your native species. You can validate your mark recapture models. And the really cool aspect of this tag, which we now offer, is that it'll actually give you time since predation. So if the predation event actually happens outside of your array, but that predator comes back in with that tag still in its system, it will still be transmitting that ID, and it will also give you a time frame of when that predation event actually happened. So you still are able to get some data. And so basically what happens with this tag, or the technical side, is that it's a direct measure of digestion. So when a stomach acid digests a polymer on the tag, that's when you will get, in the 69 kilohertz world, you'll get sort of a similar sensor value like you would get for a temperature or pressure tag. And then that's actually converted to a day since predation idea. And so some acoustic data storage tags, which is taking 2 technologies. For anybody who's used data loggers and acoustic tags, we sort of combine the 2. So these tags function in the same way within an array. They still will ping out your ID or sensor data. And then, but it's also actually logging, and it can be logging independently, so at an independent rate. And then there are buoyancy options. So the orange colored style actually does have some buoyancy. So if they pop off an animal and they can be found with a label on the beach, then anybody can get that. Or if you have a really good recapture fishery, that you sort of have a lot of programs that are able to do this. And so this is a great, it's a great 2 complementary technologies in the 1 tag. And then even if your animal is not recaptured, we've actually implemented some summary data. So if that animal swims within an array, it will actually offload some basic summary data about the full data set on the tag. So you can get some, the min and max or an average over time for that information. So it's not a complete lost cause that animal goes and you never see that tag again. And then so gliders, we know this has been a huge level of development, particularly within the different networks. And so for anyone who's been using a VR2C for their remote vehicles, we've actually sort of sunsetted that product, and we've introduced the RX Live cabled receiver. And so this allows us to have a tighter fit and some better technology, detection technology for doing that. And then we've actually are in the middle of developing some smaller factor modules that will allow for the offloading of some of our larger 5-year, the bigger receivers that allow you to actually offload data from your remote vehicle. And then the aqua measures. So in the previous talk there, Chelsea was talking about sort of applying the environmental data. And so we've developed the next generation of our data loggers. And so with these, you have a variety of different environmental conditions which you can monitor. So DO, salinity, turbidity, chlorophyll, the blue-green algae. And so these also function like a tag. So you can place them through your array and actually get some environmental data within with your fish detection. So you can kind of line up what type of conditions your fish are experiencing while they're swimming around your array. And if you're using one of our new live systems, you can actually get real-time environmental condition updates. Great if you're in areas that go through a lot of the toxic algae tides and things. You can sort of get that information in real time. And it allows you to, again, integrate that fish behavior environmental data and just get a better sense of what's actually going, the why your fish are going where they're going. And then finally, we've got a new name, but our level of support is still the same. So we just kind of remind everybody that you can call us or email us at any time if you have any questions about any of the gear that you're using, or if you need help with some study design, if you have unknown IDs. And we've also introduced a new support community. So you can get a login, you can contact myself or your sales rep for more information on that. But this is generally where you can find answers to frequently asked questions that we're sort of continually updating. It's where you'll go to grab your software downloads, any manuals, data sheets, quick guides. And then if you actually go through the login process, you can actually get your purchase history as well as tag specs and sort of keep track of any support tickets that you might have going on through that. So I think Aaron's going to take over and talk a little bit about the Ocean Aware project, which is a big thing happening here in the north.
Yeah, thanks, Courtney. Yes, we're really excited to be part of the Ocean Aware project, which is one of the initiatives under Canada's Ocean Supercluster group of projects. So we've got some really neat technologies that we're working on as part of this. It's really kind of a 2 or 3 year time horizon for us to start bringing some of these things into market. But where we're focusing our view with these is really looking at improving mobile tracking. So Courtney mentioned earlier the newer receiver we have for remote operated vehicles. We're continuing to kind of advance that work by trying to find ways to improve hydrophone designs and technologies that can be used in mobile vessels, starting on the kind of ROV side of the slower speed vessels and looking to move our way up to faster moving vessels, being able to do some mobile tracking there. We're developing a tag that kind of combines a number of different sensor options that we've designed over the years, including the predation tag, to do some mortality sensing. So having a tag that can indicate whether the tag thinks that this animal is currently dead and how long it may have been dead for. Looking at ways of being able to measure stress hormones using tag technology. So again, sensor values can be transmitting biological information about the animal while it's still moving and understanding behaviors. We're working on some machine learning things for being able to track tagless fish. So being able to use video to understand fish and identify some species within particular areas. So maybe around hydro dam facilities or other kind of high residency situations. And one place we've been spending a lot of time, and I'm excited to kind of walk through a few slides here with you to show you how far we've come with it, is really on our advanced data management processing tools. We realized that one of the hardest parts of acoustic telemetry is kind of working with all of that data that gets generated and collected as a result of doing these studies, and trying to get that to a point that you can manage it to turn it into knowledge can be challenging. And we're trying to build tools to help with all of that. So I believe it was probably about this time last year, we last had a conversation about all of the things Fathom related that we're doing. So Fathom is the new brand that we've given to all of our software. It consists of kind of 5 different pieces of software: Fathom Connect, Mobile, Central, Position, and Live. And just to kind of quickly walk through those on kind of what each of them are and how you can integrate them into your studies. So Fathom Live is the software component to our real-time live system hardware. So this can be deployed either contained within a buoy if it's somewhere offshore, or there is also a version that comes kind of in a watertight box that can be put on a bridge piling or somewhere on shore if you're close enough to kind of run a cable to the receiver in the water. And then as that receiver is getting detections, it's sending that information real time back to a dashboard that looks a lot like the one you see on the iPad here. So you can get notifications about animal detections. Those can be right here on the dashboard. They can be pushed via email. They can come through a text message. You can look at environmental monitoring as well, as Courtney mentioned, with the aqua measure. So at the same time, you can set up notifications to get information about changes in environmental situations in real time as they happen. As those sensor values change, that's transmitted to here on your dashboard. Fathom Position is kind of a DIY version of our fine scale positioning. So this is a tool that allows you to import all of your detection information, a lot of your array information, and calculate your own fine scale positions. There's some training to get you started on that, and it's really a great option for someone who wants to do a number of positioning studies in a relatively short time frame, or look at a bunch of smaller studies. I know sometimes through the year, the queue for our VPS team can back up, and you could be looking at a number of weeks before your positions are available. If you're interested enough and confident in kind of using a tool like this gives you that ability to go from having to wait for our consultants to be able to process your data set to being able to perform some of your own fine scale positioning analyses using the same tool that our teams use. Fathom Connect is the desktop-based software for currently our HR2 and HR3 receivers, but this is certainly going to be the replacement for View, as it were. So that's probably a little bit of a longer time horizon for us to get everything migrated over from View, but moving forward, Fathom Connect will be kind of the one piece of software for connecting and configuring and working with all of your actual Innovasi hardware. You'll do that with Fathom Connect, and we'll see View right off into the sunset. Fathom Mobile is a mobile application that allows you to both track some new metadata, so you can record information about any animals that you've tagged. You can associate a tag with that animal, capture a lot of the tagging and biological information that you might be capturing as part of that practice. You can also deploy receivers and sync tags in places if you're deploying those as well. Capture all of that information. It syncs it back with Fathom Central, which we'll see here in a second, and you can share that with other folks within your group using Fathom Mobile, and you can also connect to your VR2 family of receivers to perform those offloads using a mobile device rather than having to take a laptop into the field to do that. So the mobile device will offload the receiver, the data will be stored on your phone, and it will again automatically sync back to Fathom Central, where you can then export it for use in other tools. You can share it with other people within Fathom Central. So Fathom Central is our kind of newest tool for managing all of this metadata. We've designed some tools here to allow you to keep track of receiver deployments, animal tagging information, and to help manage your device inventory. So you can keep track of which devices are out, when you've last done battery changeovers, all of that kind of information can be tracked within Fathom Central. And a new feature that we've just kind of launched in the last couple of months that we're seeing lots of uptake on, that I think a lot of folks could use, is what we're calling workspaces. So it's essentially a shared environment that allows you to kind of build your team within Fathom Central, and you can share all of that information. So I can import devices that I've purchased. If Courtney and I have a shared workspace, she can bring her devices in. So you're able to see everybody's devices, whether that's receivers or tags. You can set one deployment to say this receiver was in this particular location from date A to B, and then everybody has access to all of that information within the workspace. You can have your own study that's using the shared data from the workspace, but not necessarily have anybody else using that study. So it really allows you to share all of that information without having to, I know in the past it's often been a thing to update sales orders so that someone else has permission to view information about a device. We can kind of get around all of that using the workspaces within Fathom Central without having to go back and update sales order history. You're also able to invite people. So If someone's not a member of Fathom Central currently, it's free to sign up. You can just go right to fathomcentral.com and click sign up and sign up in moments. But if there's a collaborator that you have that you want to invite, you can go into the workspace, you can send an invitation to them, and if they're not a member, they'll be able to sign up right away as part of that flow, or if they are a member, they can come right in and join your workspace to be able to start sharing and collaborating on their data. And I think that's everything from us for today.
Great.
Any questions?
Yeah, we have time for a question or two if folks have questions. I think it looks like Dave Secor, you raised your hand, so go ahead and ask your question.
Can you hear me okay?
Yep.
Yeah, thanks very much for that presentation. Always exciting to hear from you folks. And now I know I need to log on to get to those nice spec sheets that I missed so much. I appreciate that comment as well. In the Mid-Atlantic here, you know, we're moving more towards, some of us are moving more towards external acoustic tags to get at things like bycatch mortality rates. But it's a cool thing to put an external tag on a fish because they're large sometimes. We have fouling issues here. We've got disease issues here. And I wanted to know if you try looking at any innovation here in terms of releases. That would be very, even with your data logging tag, it would be nice if you could build a release mechanism, programmable release mechanism, much like we have with satellite tags. Is there any movement in that direction, Aaron? Thanks.
Certainly. I know that we are looking at some solutions for biofouling with equipment generally. So that's something we're always kind of interested in, is ways that we can help design products or offer options for people who are doing external tagging to keep that biofouling down. We haven't kind of, that I'm aware of, gone down the road yet on a release mechanism for the acoustic data storage tag, but that's certainly a very interesting suggestion, something that I'm going to take back to our R&D team and start looking in. It's a great suggestion. Thank you, David.